So day 35. So logistic regression, we are understanding the classification. What do you mean by classification? Dog or cat? Yes, no. Dog or cat? Yes, no. And other things. Similar, the things which are on the similar thing. Now, so if you can see the sorry, accuracy of, accuracy of what? Classification models. So how do you calculate the accuracy of the classification models? So when you say the accuracy classification, just go here. The accuracy, correct classifications upon the total classifications. So accuracy classification, the true false positives and the negatives are used to calculate the several useful metrics for evaluating the models. Which evaluation metrics are most meaningful depend on the specific model and the specific task, the cost of the different misclassifications, and whether the data set is balanced or imbalanced. So that is dependent on this. Now if you see, because it incorporates all the four outcomes from the confusion matrix. So what is confusion matrix now? The probability score is not reality or the ground truth. There are four possible outcomes for each output from the binary classification. The probability score is not reality or the ground truth. There are four possible outcomes for each output from a binary classifier. For the spam classifier example, if you lay out a ground truth as a columns, the model's predictions as the rows, the model prediction as the rows. The following table called the confusion matrix. The predicted positive, actual positive, TP, true positive, predicted positive and the actual positive. A spam email correctly classified as a spam email. There are the spam messages automatically sent to the spam folder, predicted positives and the actual positives. So predicted positive, but actually it is a negative. This thing is called as the false positive. So this guy has predicted positive, but actual it is the negative. So if you go our thing, so the true labels and the predicted labels, right? Not athlete, athlete, and the athlete. So if you see once again, predicted negative, but it is actually positive. The false negatives, a spam email misclassified as not spam. These are the spam emails that are not caught by the spam filter and make their way into the inbox. So these are not actually the spam emails, but they considered as a spam. The predicted negative and actual negative, TN. So TP, FP, FN, TN, true negative. They are negative and actually it has been taken as the negatives. So in the confusion matrix, this table is called as the confusion matrix. Notice that the each row gives the predicted positives. Each row gives the predicted positives and all predicted negatives, regardless of their validity. So this row gives predicted positive, predicted negative. Each, remember that the total in each row gives the predicted positives. TP true positive, FP false positive, and predict and all the negatives, that is false negative and the true negative. The total in each column meanwhile gives the real positive TP plus FN. TP plus Fn. So if you see here, the total in each column, this is the column, gives the real positives TP plus Fn. TP means true positives and the false negatives. What it will give you in column gives you the real positives. You will get the real positives. Total in each column meanwhile gives all the real positives. Column true positive and the predicted negative. True positive, predicted negative. Actual positives, actual negatives, right? And all the real negatives, Fn plus Tn, sorry, Fp, false positive, and the true negative, false positive and true negative, regardless of the model classification. The total in each column, meanwhile, gives the real positives, that is Tp plus Fn, and all real negatives, Fn plus Tn, regardless of the classification. So whenever you look at our matrix, this is called as the confusion matrix. Rows give you the prediction. True positive. What is the first thing over here? True positive. So this thing is a true positive. This is what? False positive. True positive, false positive. Here false negative, predicted negative, and the true negative. So each row gives you the predicted positives TP plus FP and all predicted negatives Fn plus Tn, false negative, true negative, regardless of the validity. The total in each column meanwhile gives the real positives. So total in each column TP plus Fn gives you the total in each column meanwhile gives the real positives. So TP plus Fn, you'll get the real positive. And all the real negatives, Fp plus Tn, false positive plus true negatives. That will give you the real negative. So when you talk about the confusion matrix, right? So just a minute. So it will give you the exact accuracy. It will give you what? The exact accuracy. So not athlete and not athlete means what? Means what? So interpretation of the confusion matrix we are understanding over here. How do you interpret this thing? If you see the 0 0, the color 1 is nothing but the dark blue, 0 is nothing but the white. A confusion matrix is a table that is used to evaluate the performance of the classification model on a set of the test data for which true values are known. It allows us to visualize the performance of the algorithm. So true positives, the model correctly predicts the positive class. So if you see, if this is 1 and not athlete, athlete is 1, so it is the true positive. These are the true labels, these are the predicted labels. Along the rows, these are the predicted labels, 1 0. And this is the, what you can say, the true labels, 1 1 1 0. So when you say TP, so this guy is called as TP, true positive, 1. Correctly predicted athlete, true negative, 0. Correctly predicted non-athlete, false positive, this one, false positive. It is not a it is not, it is an athlete but predicted as a not athlete, false negative, 0. False positive, 0, no correct prediction of the athlete. False negative, no incorrect prediction of the non athlete, this one. So gives you confusion matrix gives you how exactly the predictions have worked. So this is the confusion matrix. So from this confusion matrix, right, we can come to the furthermore accuracy scores. Not athlete, athlete, these are the true labels. This one not athlete, and this is the athlete. So probabilities are here 0 to 1. So we get the confusion matrix to just identify. We get the confusion matrix to identify, what you can say, to identify the true positives, true negatives, false positives, false negatives. So here you can calculate the precision. So let's get the TP is equals to conf matrix dot 1 1. Conf matrix true positives 1 1. Can you see the location of the true positives in this matrix? First row, first column, this one. True negatives, so if you see 1 1, what is the 1 1? This guy, right, is the true positive. Hello? Sorry, this one, 1 1. So this is the 0. So this is the 0th row, this is the first row. So 1 1, this guy, this is the actual athlete. So if you see true positive, this is the actual athlete. A true negative. True negative. What is the true negative here? 0th row, 0th column, this thing. Predicted not and actual not. So this guy is a true negative. False positive, 0 1. So this 0th row, first column. So 0 1 is a false positive. false negative 1 0. So this guy. So if you see true positive athlete, this is first row, first column. So predicted as athlete and actual as athlete. So this is a true positive. So TN, true negative 0 0 means predicted not athlete and true label actually not athlete. So this guy 0 0. True negative. False positive 0 1. 0 1. False positive means what? False positive, it is athlete. True label is not athlete but predicted as athlete. True label is not athlete but actually predicted as an athlete. That is the false positive. False negative, it is not athlete. False negative 1 0. 1 0. It is predicted label not athlete and predicted as athlete. False negative. This one. Confusion matrix. So from the confusion matrix, we will add few accuracy related things. So precision. So precision, what is the precision? Is equals to TP upon TP plus FP. What is it? True positives upon true positives plus false positives. Precision, the proportion of the positive predictions are actually correct. So this is the formula, standard formula from the confusion matrix. If you want to have the precision, right? What is the precision? The proportion of the positive predictions that are actually positive or that are actually correct. The proportion of the positive predictions that are actually positive. Interpretation, higher precision values. Now run it. Okay, we didn't run this guy. Higher precision indicates that the model is making fewer false predictions. Okay, we didn't print it. Higher precision, when you say the higher precision indicates that the model is making fewer false positive predictions. There are fewer false positive predictions. This is the standard formula. Recall. What is recall? The proportion of the actual positive cases that model correctly identifies. What do you mean by recall? What is precision? The proportion of positive predictions that are actually correct. What is recall? The proportion, it is the proportion of the actual negative cases that model correctly identifies. The proportion of the actual negative cases that model correctly identifies. F1 square, the harmonic mean of the precision and the recall. The harmonic mean of the precision and the recall. So if the recall value, the higher recall value indicates that the model is identifying more true positive cases. If this value is higher, which means that model is identifying more true, model is inclined toward the true, right? Precision, the higher precision value indicates that the model is making fewer false predictions. It is not identifying the false predictions. F1 score, The F1 score provides the balance between the precision and recall. The higher the F1 score indicates the better performance of the model. So F1 score is the balance, the harmonic mean of the precision and recall. Remember that. Mean of the precision and recall. So what is harmonic mean now? So this is also again mathematical concept. Harmonic mean, if you can see, in the mathematics, harmonic mean is a kind of average of one of the Pythagorean means. In most of the appropriate average, in most appropriate average for the ratios and the rates such as the speeds is normally used for the positive arguments. So when you say this is the formula for h of, can you see, h of precision and the mean. So n upon sum of precision on the mean 1 upon x, right? It is the reciprocal of the arithmetic mean and vice versa. It is the reciprocal of the arithmetic mean. So arithmetic mean is this. It is the reciprocal. That's why n goes to the top, n goes above. So n is over here upon n into 1 upon n into 1 upon summation of your all the recall and the precisions. So if you see here, the harmonic mean of the precision and recall, that is the F1 square 2 because we have this 2, we have two elements, 2 precision into recall upon precision plus recall, right? 2 the F1 score, the harmonic mean of the precision and recall. Harmonic means what? Two elements I am having, that is the precision and recall, into, this is the standard formula for the F1 score, precision into recall upon precision plus recall, right? If you see the standard formula, and the accuracy now is calculated true positives plus true negatives upon true positives plus true negatives plus false negatives plus false positives plus false negatives. When you talk about the accuracy, it is also proportion. If you see something is getting divided, which means that it's a proportion, the proportion of the correct predictions made by the model. It is a proportion, correct predictions. That correct predictions means what? True positives and true negatives both. It's a proportion of the correct prediction by the model upon all the predictions. Proportion of what? Correct predictions. What are the correct prediction? True positive, true negative. True positive, true negative. Upon all the predictions, true positive, true negative, false positive, false negative. That is the accuracy is. Accuracy, and you can run it here. The precision 1.0, the precision 1.0. So higher the precision value, so here we can say higher the precision value. What is precision? True positives upon true positives plus false positives. It is about the positives. Look at the formula. True positives upon, it is the proportion of the positives. True positives upon true positives plus false positives. Higher the precision indicates that the model is making fewer false positives. Right? Fewer what? False positive prediction. What is the recall? A higher, you can say, if you see true positive upon TP plus FN, false negatives, higher the recall value indicates that model is identifying more true positive cases. More true positive cases. F1 score, more F1 score, harmonic mean of the precision and recall. A higher the F1 score indicates better the performance of the model and the accuracy. Here you can say higher the accuracy indicates that higher the accuracy indicates that model is making more correct predictions, provided that you have the balanced data set. However, it can be misleading for imbalanced data sets. So your data set must be balanced. Your data set must be what? Balanced. Logistic regression basics. I can cover 5 more lectures on the topic of the logistic regression. But I have tried to sum up with the required details. On each and every aspect, we can speak in one. On the logistic curve, we can speak as a separate session. On these accuracy parameters, we can speak the separate session. Excluding the math, I will not speak a single line about a math. Okay, if we want to include the mathematics, right, there is a prerequisite. If you try to add maths over here, right, or the formula, so from who have decided the formula for the precision is this, who have decided a formula for recall is this, there are mathematicians. So this is not new to the computer science. This is harmonic mean is there in mathematics for the decades, at least for 100 years. This was there. So Pythagoras, so it was there since from the Pythagoras. You getting my point?
So these are the formulas we have to remember, right?
No, you don't need to remember anything. So if you
For
see,
status we have using confusion metric.
so these are the standard formulas.
These are
So
the standard.
standard. So we didn't, as you didn't work as a mathematician here. These are the confusion matrix is there, right? This is the standard scale to identify the accuracy of your classification model. You just need to know how to calculate the accuracy of the classification model. The minute you got to know that from by looking at your data, you have looked at your data. That's why I have taken the static data. Otherwise, directly I could have started with the Kaggle data, actual data set that we are going to do in the next session. So from here you can identify this is the classification problem, right? By looking at these 2 points, I want to come to the conclusion that this guy is an athlete or not. What is this classification, right? The minute you say it is a classification, all the aspects should become, if it is a classification model. So what algorithms are there in the classification? Scikit-learn classification models. If you go in the supervised learning, okay, just go to the official website. And here, can you see the classification? Can you see algorithms, gradient boosting, nearest neighbors, reinforcement learning, logistic regression, and more? See, and more in the supervised learning, right? In the supervised learning, how many classification models are there, right? Just go back over here. Applications, spam detection, image recognition. Which algorithms to be used? gradient boosting, nearest neighbors, random forest, logistic regression. We have covered one algorithm over here, logistic regression. This is what we have covered. So in the regression, predicting the continuous valued attributes associated with an object, we have covered one thing, that is nothing but what is the linear regression. So there is a clustering also, support vector machines. A lot of other things are there, right? But until and unless you get a mastery of whatever we have done so far, don't move ahead. So basic classification, logistic regression. But under the classification, there are many models. If you can see ordinary least squares, OLS, ridge regression and the classification, lasso regression, multitask lasso, elastic net, multitask elastic net, quantile regression, logistic regression, Bayesian regression, least angle regression, multitask elastic net, passive aggressive algorithm. So these are the standard methods which are used to identify the things. Now you need to decide. Now you need to decide as per your data which algorithm to be selected, which requires amount of judgment, right? Stochastic gradient descent. You don't need to do anything from sklearn, linear model, twisted regressor, sorry, 2D regressor, power 1. So you just need to know what type of data you are having. You need to know what type of data you are having and which algorithm to be used. If you see, implement the generalized linear model for the Tweedy distribution. Now, what is the Tweedy distribution? If you go here, but Tweedy distribution maths, if your data is something like this, if your data, let's have the image. In probability and the statistics, the Tweedy distributions are the family of the probability distributions, which include the purely continuous normal gamma inverse Gaussian distribution, whatever. So go here and just search for the 3D distribution. So if it is something like this in your EDA, you got to know that your data looks like this. In the EDA, you got to know that your data is something like this. The 3D distribution has a point mass at the 0 before following a regular exponential. Can you see? So it has the point mass, something is bigger over here. Before following the regular exponential curve, the 2D distribution has a point mass. So your point mass means what? At this point, your lot of data points are aggregated. Immediately, you should get to know that, okay, which algorithm I need to use? The 3D distribution. Now your EDA is showing you data points are spread across like this. Use ChatGPT. Now let's save this thing. Save image as desktop. Open the Gemini. So my data is distributed as per below image, and I want to use scikit-learn. Scikit-learn to predict my values. Which algorithm shall I use? Can you see that? Send it. Understanding the distribution, right skewed distribution. Can you see? Decision trees, random forest, gradient boosting, and the XG boosting. Fast and efficient implementation of the gradient boosting. It is something different. Gradient boosting, random forest. So if you see that, when with the skewed data, it is important to choose the algorithm that can handle non-normality as well. So here are some few algorithms. Okay. Now, first step is the EDA. We talked about that. So whenever you do anything, the first step is the EDA. The first step is what? Scikit-learn, go here, supervised learning, supervised, unsupervised model selection, visualizations, dataset transformations. So first step is the EDA. If you go over here, data pre-processing, before this also, you get to know about your data. You get to know about your data. So from the data, so this analysis, all this analysis will help you in understanding which algorithm should be used. So in next lecture, you'll get to know how do we do exactly these things with the classification model. We are going to have the actual classification model. But understanding the classification model is really important, the way we have done this thing. Right. Now, the Gemini, let's go to the Chat GPT and let's try to ask the Chat GPT. Which algorithm shall I use? Go here. See now? The histogram. Can you see 2D regressor? For the type of data, the 2D regressor for the scikit-learn is a good fit. Can you see? So it has automatically suggested which thing to be used. Gemini have failed if you have used the Gemini, and that's why if you want to take the call on the basis of these chatbots, first thing, you will do the rigorous analysis. First thing, you will do the rigorous analysis of the all algorithms. So here on the official website, you will get all these things. Right. Nowadays, ChatGPT exactly have suggested the 2D regressor from the scikit-learn is a good fit. Right. So zero inflated data, many zeros, continuous data with the long tail, and mix the discrete outcomes. So zero inflated data, many zeros. So over here, many zeros in your data, there are many values which are on the zero itself. So this case is the clear case of something different. If this was not there in your EDA, you didn't find that this thing, and it is normal distribution, it was the clear. You can use the logistic regression over here to decide the things, or the linear regression over here you might have used. And that's why the visualization of the data is really important. We have seen that EDA can be done visually, non-visually. If you don't like, some people have got that much excellence in the field, they don't need to even look at the diagrams. By looking at the numbers only, they got it. Yeah, it's a 2D distribution. You getting my point, guys? And that's why it is absolutely not necessary to remember anything. And in the era of the ChatGPT and the Gemini, you don't need. So this guy has, okay, now you can say you have, I think you have missed. There are a lot of points which are on 0, and then there is right skewed distribution. That is, first many points on 0, and then right skewed distribution. So what shall I use? So which algo shall I use from scikit-learn? Now let us see. You have so it has not understood that. It has not understood that. Now see, it is giving you wrong things. It is saying that this guy is an outlier. Consider this as, if you consider this as an outlier, you will get the wrong results. This could be the outlier if the values of this 0 are less than this height or inside this height, right? So this point is ranging within this height only. In that case, you could have considered this guy as an outlier. But the segregation of the points are the way higher than the maximum number of result over here. So the spike is the way higher. So you cannot consider this as an outlier. So Gemini is giving you the wrong answers. Now, what if you follow the Gemini in this case, the decision trees? So the ensemble of the decision trees, random forest can further improve the accuracy. They can handle the 0-point cluster and the skewed effectively. This is also okay. So random forest can also handle this kind of distribution. But we are looking for the accurate answer. And who have given the accurate answer? ChatGPT. Remember that all these things would be getting built with the experience and your practice. The amount of time you spend with these things will increase your judgment of selecting the algorithms. Right? And they have given choosing the right estimator. So if you see, these many algorithms are there. These are the cheat sheet for this thing. Everyone gets the thing. Start over here. Samples are greater than 50s. Yes. Then predicting category. Do you have labeled data or predicting a quantity? If you have a labeled data, right, then how many samples you have? 100 then less, 100 then k. Then linear SVC or stochastic gradient descent, SGD. Can you see they have given the cheat sheet, choosing the right estimator. The question you have got, everyone get the same question. So they have given the path. But still you need the judgment. But still you need what? Judgment. You may refer this diagram also. Again, I'm saying it is not necessary that you should be knowing all these algorithms. It is impossible to know all these algorithms. Right? So for supervised, they have supervised and unsupervised learning. They have 1 point, means they have 17 algorithms. And unsupervised, they have 9 algorithms. Scikit-learn doesn't give you any idea about the reinforcement learning. right? So in the next session, we will talk about actual things. So one thing I would like to clear over here. Now, if you see in the supervised learning, the last algorithm is a neural network, right? And in the unsupervised learning also, there is a last algorithm is a neural network. Hello? Am I audible? Hello? Power failure at my end. Power failure at my end. I'm closing the recording.